Yeah, I'm here today to talk about progressive web apps, and we're going to kind of focus a little bit at the end on offline development and how to make your web application actually work offline. I'll start by talking a little bit about myself. So I'm a full stack developer. Primarily, I work in the LAMP stack, but I do a little bit of Node as well. I'm the lead at Maiden Academy, which is a bootcamp / training company in Bath. Basically, my job is to learn new stuff and then tell other people about it, like I am now. So let's talk about what a progressive web app is, just to remind ourselves if we don't know. So the Wikipedia definition is progressive web apps are experiences that combine the best of the web and the best of the apps, which obviously is really clear to everybody, so we can probably just go home. So actually, what is it? So Alex Russell coined the term back in 2015. They've actually been around as a kind of concept or thought project for a lot longer than that, but he wrote an article sort of actually coming up with a practical way of doing this. The idea is that it's a web application that appears to be a native application on pretty much any device. So rather than having a native app, a web app, and maybe a desktop application as well, where you might have to have 3 dev teams building each one, and you get like inconsistent UIs between each one, and you have like the project managers coming up with different features and like all sorts of weird things where like that one does this thing, but this one doesn't. And the idea is you just build one application and it runs across all platforms and looks like a native application everywhere. They are supposed to be able to work offline, hence we're going to talk about the offline development stuff. And they, supposed to be, as it says, operating system agnostic. So they should work on mobile devices, desktop devices, just everything. Microsoft actually tried to do this a few years before Alex Russell came up with the term PWA. They did it with one of the early versions of the Windows mobile operating system, but it didn't catch on. Nobody did it until the whole PWA kind of thing came up. The actual article is on here. I will share these slides on Twitter later. So if you want to read Alex's article, it's there. So what is it? Well, it's actually just your pre-existing web application. You kind of don't really need to do a lot to it. You can just use your existing web application, your HTML, your JavaScript, CSS, everything as it is, and just add a little bit more JavaScript to it to make it do some other stuff. So at the moment, if you want an app on your mobile device or a desktop application on your computer, you have to either go to the website, download it, or go to an app store, download it, install it, and then start using it. Whereas to use a web-based application, you just go to the URL and use it straight away. There's no installation, there's no kind of pause. So the idea of a PWA is it's use it to install it rather than install it to use it. So what happens is when you start using the web application just through the browser, after, depending on what browser you're using, after a certain amount of time, it will just trigger a pop-up and say, do you want to install this? You just click yes, and it will just silently install in the background, and you don't have to specifically go somewhere to install it yourself. I've got a GIF in the next one, which will kind of show you how this works. The GIF's quite fast, so I'm going to leave it up for a while so that you can see it run a few times. The GIF's actually quite old as well, so it's using the old notification style. So if you've seen like the old and the new one, you'll notice that they're a little bit different. I couldn't find a GIF that somebody else had made with the new one, and I didn't have time to do one myself. But it's basically the same principle. So you go to a URL, so just Google something, gives you your application. After you've used it for a bit, it gives you a pop-up, which you click to install to the home screen. Go back to the home screen, you can see it pops up like a native application. You click it and open it, and it goes back to the actual application, but it's got rid of like the URL bar, and it looks like a native app. I'll just let you watch that again. Yeah, does that make sense? So the one bad thing about this GIF that it doesn't highlight, which I feel is a really important point, is when it installs to the home screen, at the moment it's installing just using the Chrome icon to the home screen, so it just looks like a bookmark, but actually you can customize that icon so it does look like a native app. I couldn't find a GIF with that example. Okay, so we know kind of what a PWA is, so why would we want to do this over something like React Native? So I've got a couple of case studies. First of all, it's really quick. So Tinder were one of the first kind of big companies to actually do this. They do obviously still have native applications, but their web application, they've implemented the PWA code, and that meant compared with the original web app, which average load time was nearly 12 seconds, they cut it down to just over 4.5 seconds. Mostly that was down to the ability to control the cache through your JavaScript, which we'll talk about in a bit. Uber did it as well. So they decided that what they wanted from their PWA was for it to be as small as possible and for it to use as small amount of data as possible, so that no matter where you are, if you're stuck in the middle of the field and drunk or whatever, you can still get a taxi. So they created a PWA which gzipped is actually only 50K. The whole application of Uber is just 50K. And it means that actually now you can install the whole thing or load the whole thing and actually get a taxi hopefully in under 3 seconds on 2G, which is pretty good. Hopefully we're not actually ever on 2G anymore, but all this is in comparison with the native mobile app, obviously, which if you don't already have installed, you have to go and install, and that would take forever on 2G, and you'd definitely die in a field. Trivago then are another company that have done it. So these stats are in comparison with their web application before they implemented the PWA technologies. So they saw a 150% increase in user engagement. Obviously pretty handy. 97% increase in hotel offer clicks, and 67% increase in users continuing to browse when they go offline because of the offline support. Obviously, previously, if you go offline, most people would just give up, no signal. Most of this, again, comes from speed gains, from cache control, and from the push notification stuff and the offline support. We're going to talk about all of those things. Last one, Pinterest. We actually saw their logo earlier because they do have a React Native application, but they've also implemented the PWA tech into their web application, which resulted in a 60% user engagement increase, a 44% increase in user-generated ad revenue, and a 40% increase in the amount of time actually spent on the application. Those stats are versus the just normal web application, not versus the native one. But actually, if you want to compare the PWA to their React Native one, they did see in all three of these stats between 2 and 5% increase on all three areas versus React Native. So actually, it is quicker. So let's talk about the tech behind it. How do we turn your application into a PWA? You kind of need 3 things, but kind of 4, so we'll talk about that. You need to be running your application over HTTPS. You all already are, so we're fine, obviously. You need a web app manifest, which is essentially a JSON file containing the settings for your application. We'll have a look at that in a minute. You might need a service worker. You need a service worker in everything except Firefox. It doesn't require one. We'll talk about what a service worker is, but it's basically a client-side proxy. Allows you to control your HTTP requests. And you need the user's permission to actually do all of this stuff. So we'll have a look at that as well. So let's start by getting users' permission. So if your browser supports service workers and PWAs and all of the tech required, then there's an event called the before install prompt event, which will fire after a amount of time when the user visits your application. So on Chrome, or in the latest version of Chrome, which is version 68, if the user has been using your application for more than 30 seconds, then that's when the event will fire. Different browsers have different rules around how quickly that event will fire, and they change it all the time. So it's at some point, but it's usually fairly quickly. Once that event fires, you can then the event will only fire if all of the install criteria are met. We'll go over that, but it's essentially if you're running on HTTPS, if you've got a manifest JSON file, the stuff we just talked about. Once the event has fired, you can then hook into that event, and it's got a prompt method, which we'll see in a minute on it. You call that prompt method, and that actually shows the pop-up. Some browsers require the prompt method to be triggered based on a user interaction. So you might have to click a button and then get the prompt thing. So we'll have a look at that as well. Once they accept the prompt, then it will just install in the background. There's no downloading, installing bar. It just does it behind the scenes. You don't have to watch it. So the code for this would look something like this. I'm just going to kind of give you a minute to read through. I assume everybody here knows JavaScript. So we're just assuming that I've already selected the add button because I ran out of room on my slide. Okay, so what's going on is I've created an event listener for the before install prompt. After that fires, I've picked up the event, displayed my add button. When the user then clicks on that button, I'm calling prompt on the event itself, which that actually displays that pop-up that you saw that says, do you want to install this to your home screen? Provided that they accept that, it returns this promise, and you can do stuff with it, or you can just do nothing because it's already doing the install for you. But if you want to run code whilst that's happening, you can. Yeah? Okay, so let's have a look at the other install requirements. So the web app manifest. This is a JSON file that you have to include into the head of your HTML document. These are just the required fields within the web app manifest file. There is actually loads of optional fields that you can put in there to configure all sorts of different things. But essentially, you kind of just configure the background color of your application, the name that it will actually display once it's installed to the home screen, the start URL, so when they click the icon, which page it actually goes to. It doesn't have to be the home page. Description, which is kind of like a longer description about what your app does. Display allows you to make it open in the browser or as a standalone thing, so it looks like it's its own application. Generally, that's the one you want to go with. Icons, which is an array of different icons, so you can provide them at different sizes for different resolutions, so it can support lots of different devices. And then orientation, obviously, which way it should open within the phone. Like I say, there are lots of other available ones that you can put in to do different things, but these are kind of the default set that you want to start with. So if you're, actually at this point, you've pretty much got a PWA if you've done those two things, but only if you're using Firefox. If you're not using Firefox, then you have to have a service worker installed. So let's talk about what that is. So it's kind of like a client-side proxy. It essentially sits between the browser and the server, but actually on the client side. And it sits in its own execution thread, so it's separate to JavaScript. It can interact with JavaScript and the DOM, but only through special APIs. It doesn't have direct DOM access because it is in its own thread. So it's got this post message API, which gives it the ability to kind of communicate with the other thread that JavaScript's actually running in. But generally, you kind of don't really want it to do that anyway. The idea of it is that it sits there to interact with all your network requests. So anytime an HTTP request goes in or a response comes back, it will be picked up by your service worker, and then you can do stuff with it. We'll talk about the kinds of things you might want to do with it in a minute. Most commonly used for cache management, so actually storing stuff in the cache, not just files, but data. So let's have a look at how we do this. So this can go in an external file, but generally we would just put this in a script tag in the head of your HTML. We start by just checking that the browser supports service workers. The service worker property is inside the navigator global. If it is, then we can call navigator.serviceworker.register, and we point it at our service worker file. So that's actually your service worker. You don't actually have to have anything in your service worker at this point. You can just register an empty one, but it will register that as your service worker. You have to give your service worker a scope, which is essentially what it can control. So you can say that this service worker can only interact with network requests coming from a particular file or a particular folder. or if you just give it root access like everything, you can, yeah. It's all promise-based, so that returns a promise, which is obviously successful means that it's installed the service worker, or failure falls into the catch and it hasn't because whatever reason, maybe you've got an invalid service worker, and I've just put a little console.log in for the else, so if it's not supported. Yeah, that's it. We're done. Like, you don't need anything else in all browsers now, provided that it actually supports all these technologies. You could actually, that's a PWA. Now you go to your application, the prompt will pop up and you can install it and actually you're done. But probably not, because you probably want the service worker to actually do some stuff. So let's talk about some of the things that we can do with the service worker. As I said earlier, the most common thing that you would do with it is cache management. So once you're inside the service worker file that you've just registered, you've got this global called self, which essentially refers to the service worker and comes with a whole bunch of events and functionality methods and things that you can call on it. So here I'm listening for the install event. This one obviously fires as the service worker itself is being installed. The event that comes back from that has this method called wait until, which basically allows you to do stuff whilst it's installing, and it won't have finished installing until you've run that code. So all I'm doing here is hooking into the cache API, opening a new cache, and adding a CSS file to the cache. So now that's available offline. I don't have to go to the network to go and get that CSS file ever again. We can also hook into the fetch event, which is the HTTP request event. This event does fire whether you're using XML HTTP request object or the newer fetch. This will hook into literally every single HTTP request, whether it's done from your JavaScript or by the browser. Every request will come through this event. So here I'm hooking into the event, and I'm checking whether the thing that the fetch is looking for is already in my cache. So if the event is for that CSS file that I've just cached, it will get it out of my cache and return it. So it's returning my actual cached file. If it's not in my cache, then it will just forward on the fetch request by literally using the fetch method function and doing event.request and just kind of forwarding it onto the actual network. So now I don't have to go back to the network to re-get my CSS file every time. I just pull it out of my service worker's cache. So that's kind of basic use of a service worker, but we can do a lot more with it. We can actually control our HTTP requests and do some quite more exciting things with it, and this is where the real speed gains can come from. So how about if we want to only get data from the API once every 5 minutes, because the data doesn't update that often, we don't need to re-get the data on every new page or every time a user interacts. Rather than actually editing our already built application, our JavaScript, we can do that in the service worker. So as far as the application is concerned, it's still going to the network and getting the data, but actually the service worker's returning with that data instead. So I've just chucked an if statement in here that just checks if the last time that a request was done was more than 5 minutes ago, then actually go and get the data. And if it's not, we can just return the previous data from the cache. Kind of the life cycle of what's going on here is you make an initial request to the API, you get that data, you store the data, and then display it. So you store the data somewhere in a cache or something. The user performs either a refresh or a page change or some interaction, which requires the data again. The service worker then picks up on the fetch request where you're trying to go back and get that data and can decide how to respond. Yeah, we've already got that data in the cache, we'll just give it back, or no, that data is more than 5 minutes old, so we'll go and get some new data. The service worker responds with the data. As far as your actual application is concerned, it's the data from the network, it doesn't know any different. And then obviously your application just updates the UI as normal. So the bit that we actually need to talk about is this bold bit over here, the whole like stores data thing, like how does that happen? There's a couple of different client-side data storage things. So there's the service worker cache, which we've just been talking about. This is generally designed for storing files. You can actually store data. You can like on the fly generate JSON files and store them in the service worker cache. Don't do this. Like the JSON is not searchable. It's like a text file. It's just a terrible idea. There's the local storage API. it's a synchronous API, so therefore it doesn't work from the service worker. Service worker has only got access to asynchronous APIs, so you actually can't use this one. A lot of people are already using the local storage API on the front end to store their data. Sorry, can't use it from your service worker. So instead what we want is IndexedDB, which is an asynchronous front-end database, basically. It's a database that runs in your browser. It's an asynchronous API, so we can store data in it from the service worker, and then it's indexable, it's searchable, and it's much quicker than just JSON files. So let's talk a little bit about IndexedDB. So as I said, it's a client-side database. It's designed to store large amounts of data in usually JSON format. Like, I've given this talk a few times, and at one point I was like, yeah, it stores large amounts of data, and somebody was like, so I work with 10 billion rows. Not that much. There are limits to how much data you can store, and we're going to talk about the limitations in a bit. But yeah, it will manage reasonably large amounts of data for a front-end application at least. It uses indexes, so it auto-indexes the data that you put in, like a relational database would, which means that actually it's pretty high performance as far as searching is concerned. It's asynchronous, promise-based API, so therefore all works nicely from the service worker. And it's actually a permanent data storage. This one took me a while to find out whether there was actually a limit, but the data that you put in there will just never disappear. It's not like a session storage or something like that where it will expire after a certain amount of time. You put something into IndexedDB and it's there for the rest of ever, unless they uninstall Chrome or they clear all of their browser data. It's actually a permanent storage. As far as performance, it can do about 1K reads per second. So if anybody does actual performance analysis, you'll know that that's not super fast for a back-end application, but pretty quick for a front-end one. The write speed depends on the amount of data that you're writing and the device that you're using, actually. So I can't give you any stats on how fast that is, but it's faster than going to the network. So let's have a look at some code as to how we do it. I'm using a library called local forage with an F, which is like local storage but with an F, and it makes IndexedDB easy to do. Don't try and do this without a library. I did. It doesn't fit on the slides. It's not nice code. So yeah, I'm using local forage. So here, literally just setting my database transaction. You have to give it, essentially you give it the name of the database that you want to create. So obviously I'm using a to-do list application. You give it the permissions that you want, so I'm giving read, write. And then you give it the table, so object store is like your table if you're used to relational databases. For clarity's sake, I called my database and my table the same thing. Once you've connected to your database, you've got your database and your table connection, you then just call add and kind of just chuck data at it, and it will just store that data. It's kind of, if you've used document storage databases like Mongo, very similar principle. You just call add and here's some JSON, thanks. And it will literally store those key value pairs in a more relational kind of style way of doing it. When you call add, you can specify the key as the second argument. So you can say store this in key 1, or you can just omit the key and it will just auto-generate in the next row. Then to get the data back out, it's literally just get, key, done. There you go. There's the data next to that key. There is a whole bunch of other searching features where you can say give me all of the rows where the name is Mike or the name starts with M, or you can do some more SQL-y type querying. I haven't got any examples of that, but you can do it. And depending on the kinds of querying you do, you get mixed results in speed. Sometimes you crash Chrome. But yeah, cool. So yeah, and then in addition to get, we've got the put, so updating essentially. So here I've just changed the name of the data that I just got back out and then called put with the key of 1, and that just updates that row for us. So fairly simple to use. So let's go back and have a look at the code that we had earlier where we were only calling the API every 5 minutes. Now that we know how to use IndexedDB, we can actually start to put the two together. So here I'm doing if the request is older than 5 minutes, forward the request on, so actually go to the network and get the data. Once we've got the response, so we've got the response data here, I'm adding the response data into IndexedDB, so I'm just saving it for later, so it's now offline, and then I'm just returning the response. So just send the response on. Once I've saved it, I'm going to also send it on so that our front-end JavaScript actually has the data as well. Otherwise, if it's not older than 5 minutes, if it's a recent request, then all we're going to do is just call the GET request with the ID from the request body, get the data out of IndexedDB and give it back to us. So not actually too much code in order to get that working. So let's talk a little bit more about offline development. So the things that we've done so far, obviously, are the beginnings of offline development. The whole 5-minute thing was just an arbitrary thing I made up. But actually, unless you were going to the network, that would entirely work offline. If we cached all of our files, all of our static files like our CSS and our images, and then we've got our data stored in our front-end database, we just don't need the network anymore. Our application will just run completely offline. So there are some implications that we need to think about when we're doing this kind of thing. Most importantly is the UX implication of this. If you're doing something like financial data or train times, probably don't tell the user it's live data, or probably tell them it's not live data, more importantly, because we all know what trains are like. So yeah, there's a big UX implication of this, so we're going to talk about how you do that. Okay, so let's have a quick look at how we actually make this kind of work with offline stuff. So here, my fetch request that's actually going to the network to get the data. Obviously, this will fail if you're not connected to the internet. So we need to handle that scenario. I ran out of room on my slides, so just imagine we're in that purple bit now. It's actually really easy. The fetch request will just fall into the catch if it fails. So in the catch, we can just go and get the data out of IndexedDB again, and just be like, look, here's the data, it's done. Yeah, it's actually, that bit's fairly easy, but I just couldn't fit it all onto one slide. The fetch request within the service worker is really responsive to offline, and it'll actually detect whether the application is connected to the internet, rather than trying and waiting and hanging and then failing. It will just go, no, you're not online, I'm just going to fail straight away. So it's actually a very fast response as to falling into the catch. Once it's failed and it's returned with the offline data, obviously don't forget to update your UI. We can do that actually in our application with our front-end JavaScript code because we've got these 2 events that have been added. The online and the offline events, which fire on the window anytime that your application moves from being online or offline, funnily enough. So here I've just created a quick function which displays a message or a pop-up or whatever if you're online or if you're offline, or hides it if you're online. So if you just chuck that into your front-end code, then any time that your application goes offline, it will just pop up and say, yeah, you're now offline, and we're just serving you old data until you go back online. Obviously, very important. So let's have a look at the workflow, the lifecycle again. So now we've got our initial request going out to the API to get data. The data comes back in the API response. We're grabbing that data and we're storing it in IndexedDB, and then we're forwarding it on actually to our front end. User performs an interaction with the page, which requires the data again. The service worker picks up that request, tries to get it from the network. If it can't, it'll fall back to IndexedDB and just return the data from IndexedDB. And then once it's returned the data, regardless of whether it comes from the network or from IndexedDB, the front end has no idea. It just updates the front end. All seems to work. So there are other parts of the service worker. Background sync is a particularly useful part of the service worker. This code is, every other bit of code in this talk will actually work if you were to copy and paste it straight into your application. This does not. This is like pseudocode representation because it does not fit on a slide. So here's my app.js, which is my actual like front-end JavaScript code, where I'm clicking on a button and I want to make a fetch request to update the train data, for example, like a refresh button, for example. Rather than just doing the fetch request straight in my app.js, what I'm doing is calling registration.sync.register, which registers a sync request with your service worker. So then in our service worker, we've got this event called sync, which will pick that up. We can hook into the event tag to see, is it the same as the thing that we've registered? And if it is, we can then use event.waitUntil and call the function. Now, this function is essentially the same front-end function that you've already written that was doing your fetch request. So you don't have to change that bit. You just call it from your service worker instead of your app. And what will happen is if you're offline when they click that button, it will just wait until you come online, and then it will make the request in the background. And that will happen not just in the background, like if you're sat there waiting, they can close the app, they can go and do something, and it will just send the request when you come back online. So you don't actually even have to have this running. It doesn't have to be in the foreground of your phone. It will just say, yeah, we've registered that as a background sync thing. You can now go and do other stuff. You can leave the page, you can close it, and it will just sync when you come back online later. It's more complicated than that code. It's actually really hard to do this, but it doesn't fit on the slide. But that's kind of that's like the idea of it. So let's talk about some of the limitations of PWAs, because so far I've been like, yeah, they're amazing, but there are obviously downsides to these things. Limited storage is the biggest one. So offline data, and files, so IndexedDB and the service worker cache, and kind of any other things that you're storing. Actually, there's a limit to how much you can do that. So on Android, you can store anything less than 2 gigabytes. And then each browser has their own specific requirements for that as well. So if you're using Chrome on Android, then it's less than 6% of the available free space, provided that that's less than 2 gigs. Yeah, cool, good. Same on the others. Obviously, Safari is iOS. So iOS is just, you can only store up to 50 meg, and that's that. IE10, yeah, that does support this. Yes. Yes. IE10, yeah, only 250 megs, so better than iOS, but still not a massive amount. So Edge, they have like this, if you go and look this up, they have this table where they're like, this is how much data you can store, and it's really complicated, and it's all to do with like, if you've got a device that runs at this many gigahertz per second in a field and the wind is blowing east, then you can store this much data. If you happen to be wearing a pink shirt, you can store that much data. Like, it's just really complicated algorithm. No, I didn't understand it. I don't actually have a clue how much data you can store. I couldn't figure out any part of it. So yeah, who knows? The difference, the only plus side of this actually is that on desktop devices, there's unlimited storage. None of these apply. We can just store whatever we like because it's a desktop, obviously. Well, limited by the amount of hard drive space you have. Other limitations, iOS just likes to randomly delete your data. Yay. Yeah, so if you don't use the application for a while, the PWA it's like, they changed the amount of time, but it's like a couple of weeks, like 2 or 3 weeks. They'll just be like, yeah, you probably don't need that anymore, we're just gonna delete all your data. It's not like a big problem because it's just front-end data anyway. Hopefully you're storing the data on your back end, like you should be. It doesn't remove it from the home screen. Can't do the home screen stuff yet, but it doesn't like remove the fact that the app is installed. It just like removes all the cache data and all the IndexedDB data. So then when they go back into it, you just have to re-download all that stuff. But all that happens in the background, so it's not like a big problem. But it does mean that if you had like session data, or if you were remembering the fact they were logged into an account or something, it would log them out. So that's a bit of a pain. And then the big one. This is primarily the reason that Adam didn't pick PWAs and went down the React Native one, is obviously the limited native access. So with React Native, obviously through Ionic, you have access to a lot of the native functionality of a mobile phone or a device. With PWAs, we still are limited by the browser web APIs. If you came to my talk last year where I hacked everybody's phones, you'll know that they're getting better, but it's still kind of not there. So at the moment from your service worker, you don't have access to, this is actually wrong, you do have access to Bluetooth now, because I did that accidentally. You'll know if you saw it before. So you can actually access Bluetooth, but there's no access to things like your fingerprint scanner, the Face ID stuff, no native storage access, no camera access, like all the things you want, you can't do. But it's coming. Like, it's not here yet, but most of these things have APIs that either already exist and just haven't been implemented into the service worker, or they've got APIs that are under development and will hopefully be here soon. So it's kind of, hopefully this will be there soon. Woo. And then iOS doesn't have any push notifications, which is obviously the big one. You can't do this in JavaScript. That's also coming. We're just not there yet. But hopefully that one will make a big difference. I think, yeah, cool. If you want to know more about like the web app API stuff, I did a talk here in like December, I don't know, last year, all about it. So let's talk about what this actually means for us as developers. That's funny. I wrote this talk for a back-end meetup, and I've got a note here that says, brush up on your JavaScript. Not going to say that one to you guys. You're probably better than me. So yeah, JavaScript. But kind of primarily, what does this mean? Well, it means like don't get rid of your native applications just yet, but maybe soon. Yeah, like at the moment you're probably, like if you're a big company, you're probably paying like a native app team and you're paying a JavaScript team to do the web stuff. And if you've got a desktop application as well, because loads of people got those, you're probably paying a desktop team as well. The idea of this will be that you can just fire those other two teams and just be like, yeah, web, woo. If you're a manager, please don't do that. Yeah, that's kind of the big thing, is that obviously the idea is that it will actually just get rid of the need for having different teams, and you can just build one application and just all the JavaScript. The desktop thing is like super under development. You can actually do this. It's pretty cool. I don't have any slides on it, but in Chrome, like if you go into like Chrome's config, where you can like mess around with all the like internal settings of Chrome, there's a flag that you can turn on. And then you can actually install your PWA application to your actual desktop machine, and it works like a desktop application, and like it'll appear in your applications folder, and like you can put it on the launch bar, and like it actually looks like a desktop application. It's really cool. Only works in Chrome, and it's behind an experimental flag, and it's super buggy, but it's kind of on the way. Obviously, the big implication of this is it means less network requests, less HTTP, so therefore faster applications. That's the main reason that we do this, because we can just cache all the stuff. Now our applications work offline, and we don't have to go to the network, and we don't have to bug our back-end team so much. A couple of resources on this. So there's a website called servicework.rs. Yeah, yeah, cool. This has like got all of the code that I've done today and loads of other examples just there for you. The good thing about the service worker code is it's the same for everybody. Obviously, there's specifics to do with like this fetch request or like the files that you want to cache. But generally, most of the code is pretty much the same for everyone. So you can just go here and just nick their code and then just like tweak it. So they've got examples of pretty much all of the different like offline things and push notification stuff and things through service workers. It's really good. Created by Mozilla. Sorry, do you want to take photos of this? I just click. You're like, ooh. What? No, oh, okay. Sounds like a terrible idea. Okay. So the stats that we went through at the beginning, they're all from PWAstats.com. There's a whole load of case studies on there as to people that have created PWAs and what they found their results were. So yeah, go and check that out. It's actually pretty good. It's updated quite regularly with new people doing PWAs. If you've done one, or if you're thinking about doing one and you do one, please submit your data to here, because that will be really interesting for me. Great. And that's it. Any questions?
Service workers not being required on Firefox? Or
Yes.
Can you explain a little bit more about that?
Yeah, okay, so it's going to break my clicker. Yes, okay, so in order for your application to be considered a PWA and therefore for the before install prompt event to actually fire, you have to have these things. So you have to be running on HTTPS, you have to have a web app manifest, and that's actually it in Firefox. You don't have to have a registered service worker. You used to, but they've changed it more recently. In every other browser, you have to have a service worker as well in order for that event to fire. But in Firefox, they don't require a service worker in order to fire that event. You just have to have a web app manifest and be running on HTTPS, and then it will fire the event. So it's literally just the criteria for firing that event. Okay. Yeah.
Oh, can you do push notifications then with a PWA?
Yes. I mean, obviously not on iOS, but yes, you can pick up on push notifications, and yeah, and you can push them to the client.
Is that, can you push them from your server, or is it only from?
Yeah, so you can accept sockets. So if you've got a socket connection, you can because that's still just through HTTP. It will go through your service worker, and then your service worker can pick up that socket data and create a push notification with it. So because your service worker actually installs to the phone and runs within the browser on the device, phone, whatever, it's constantly running in the background. So yeah, if you've got a socket connection and the socket connection pushes to your service worker can then pick that up and create a push notification to your front end, and they don't have to have the browser even open. I think there are some limitations on it. I think they have to still have the tab in the browser, even if they close the browser. Like, it has to still be an active tab rather than having completely closed it. But yeah, you can use push notifications with no browser open just whenever.
So you mentioned the post message API and that it's a thing, but that you wouldn't usually use it. What are some examples of when you would or would not use it?
So kind of the whole point of the service worker is that it picks up HTTP requests and then interacts with them. The post message API was created because some people were like, oh, I want to be able to update the DOM from picking up a request. But actually the whole point of the service worker is that it just interacts with the request and then forwards it on. So you don't actually have to change your UI JavaScript, your front-end JavaScript. So generally it's a bad idea to do that. You should just leave your front-end application alone, like don't touch it, and then just bolt your service worker on, and then just forward the data or the response. As far as good ideas as to when to use it, I don't have any. I don't think you should really. It was kind of created to circumnavigate that, but just the whole point of it is HTTP requests and responses, so just forward the response on. There is a weird thing which I guess you might use it for. So let me. Where is my code? Sorry. Yeah, here. So this bit of code actually doesn't work. So the response from a fetch request within a service worker is one-time use. So as soon as you've read the data, it's gone, like the data's gone. So if you grab the response and then put it into IndexedDB, you then don't have the data anymore to forward on. So actually what you have to do is you have to clone that object first, and then put the cloned data into IndexedDB and forward the original response on. You could use the post message API if you wanted not to clone it to read the data out into a variable, put that variable into IndexedDB, and then interact with the DOM directly through the post message API instead of cloning the response. That's the only place I've actually seen this being used, but yeah, again, just clone the response and forward it. Adam.
I know background app refresh native apps have kind of a time limit for execution. Is that the same for progressive web apps?
I don't know. Yeah, I've got nothing more for you. Yeah, so not that I know of. There's not in any documentation does it say that there's a. Yeah, I imagine there probably is. There's probably is some rules around, like, actually if you turn the device off, or if that there probably is a certain amount of timeout, but within the documentation for this on both, well, the Google documentation for background sync is fantastic. It doesn't say anything about it, and I've never built one to test it, so I couldn't tell you the answer, but there probably is somewhere. So you're asking if the...
You can share the code.
Yeah.
Like, I know like when you
I mean,
have to have visited it like 3 times or spent a certain amount of time before you can install it.
yeah, so it used to be you had to visit it more than twice with a 5-minute gap. Now it's just you have to interact with it for more than 30 seconds,
Oh, okay.
which is, yeah, that they have changed that. As far as sharing code, I mean, it's just like JavaScript code, so I imagine not. I mean, I guess you could open source it, but or like NPM it, but no, I'd probably not. But to pick up on something else that you put there about not imagining that you would go anywhere but the App Store to install those things, the Microsoft, the Windows App Store, actually you can add your PWA to it. So if you create your application as a PWA, you can then submit it to the Windows App Store. Within the submission of their App Store, they've got a thing for PWAs, and it's coming to both the Play and the iOS one as well. So you will actually be able to put your PWAs in the real app stores and not have to have a native app anymore. You just be able to go to the App Store, click download, and actually what it will do is it will just fire you off to the web app URL and then download it in the background. It's not here yet, but it's coming.
Are there any agreed standards for this on the way? Because all the different browsers, obviously, like I said, there's some issues with Safari being behind.
Yeah, so Google, so Alex Russell works for Google. I may have not put that down. So Google are kind of driving this. So they're the ones pretty much setting the standards for most of this. They, as they say, Alex kind of conceptualized the idea, sort of, unless you work for Microsoft. But so yeah, they're kind of setting all of the standards. They're the ones that have created all the APIs in Chrome, and then everybody's kind of following them. The big problem, and I used to have slides on this, but the big problem is obviously that both Google and Apple make just a ridiculous amount of money through their app stores, and this has the potential to just get rid of all of that money. So Google are kind of okay with that because they only make $9 billion a year from it, whatever, whereas Apple make like $23 billion a year, which is a little bit more. So Apple kind of don't want this, but at the same time, everybody actually kind of really wants this. So they're just a little bit behind the curve, which tends to be Apple's way of doing things. They'd like to be a little bit behind. But they're slowly being pressured by all the other browsers to catch up. So Google are definitely at the forefront of this and setting sort of the standards for it, and Apple are like a year, 12 months, 18 months behind. But it's coming, yes.